Hello everyone. Today we are going to discuss about vectors. The vectors is an important mathematical concept for engineering students. Basically for electrical engineers, students usually study about vector diagram to represent the phase shift between voltage and current. If we take inductors, the current lags the voltage by 90 degree. So they need to represent this in the phasor diagram as well as in the vector diagram. So today's the purpose is to provide the basic knowledge of the vectors so that you can develop your knowledge or application of vectors in this electrical engineering field. So let's look at vectors is a quantity that has magnitude as well as directions. So two things, vectors means we have the magnitude as well as the direction. That's important, magnitude as well as direction. So if you look at this picture, this point AB, this vector, AB vector, this AB vector, we represent vector with the arrow. Arrow indicate this is AB is a length and the arrow indicate the directions. So this is a representation of the vector. The vector is 3 meters. This is 3 meter and direction of the vector is 20 degree east to the north. So this is the 20 degree east to the north is the direction. So if some quantity in the mathematics which can be represented by direction and the magnitude, then that is a characteristic of vector. That is a vector. So if you want to understand vector deeply, we need to understand what is scalar. Scalar means a quantity that has only the magnitude. There's no direction. There's no direction. So this is a scalar. So 2 meter length is a scalar. We are not telling. We are just telling something is 2 meter length or rope or something. We are saying a 2 meter length or 5 meter height. Mean it is not a scalar. We are not telling the direction or this is a scalar. It is not a vector. So if some quantity is simply saying that 2 meter, 3 meter, 5 kilometer, these are the scalars because this quantity doesn't has a directions. Okay. So scalar means physical quantity that can be described by a single number and a unit of measurement. Okay. Scalar have magnitude but no direction. That's a key. There's no direction for the scalar. So now we understand fundamentally what is scalar and what is vector. So let's move on to the vector. How we represent the vector? We can represent AB with the arrow on top to represent the vector. So the A is the initial point and B is the terminal point. We say terminal point. Some books they say end point, start point, end point. It's same thing. Start point, end point, or the terminal point. This length is a magnitude. Length is a magnitude. This is a vector. Okay. So if B to A mean the direction is changed. Okay, the direction is changed, but magnitude is the same. So the B to A vector. So this is the and when we represent only the magnitude, we always put the mod sign here. We put the mod sign here to represent the only the magnitude. If we want to represent the vector, we always put a this is a vector representation. If you only representing the magnitude of the vector, then we put AB under the mod. This is a representation. Okay. So with this AB vector, in simply we put A small in the small a vector. This is always if we have a AB vector, we can say it as a small a with a vector sign as well. So this is also notation. So this is a initial point, terminal point. Here is this is the initial point, B is initial point, and A is a terminal point because B a vector. This is a AB vector. Okay, so starting point and end point, these are the matters. Okay, now we discuss about what is co-initial vectors. Co-initial vectors mean two or more vectors having the same initial point. Okay, this is the initial point for these three vectors. So this is a co-initial vector. So OL vector and OM vector and ON vector. We have three vector. All vectors are starting with initial point O. This is co-initial. Co mean, we always say co mean is like we can understand is equal, that all three vectors starting with the same point. Okay. Then collinear vector mean two or more vectors parallel to same line irrespective of their magnitude is called the collinear vector. So this vector, we don't consider the length, the magnitude mean here is a length. We just consider direction. If you look at the direction, all these vectors are in the same direction. So these are the collinear vectors. This vector, this vector, these vectors are the collinear vectors. Direction wise, it is the same directions. And equal vectors, here two vectors have the same magnitude and direction regardless of their position. That's a equal vectors. So this AB and CD are the equal vectors in terms of their magnitude, same magnitude, and direction also same, but the position is different. It's starting here, this is starting at here, but the same vectors because same length and same direction, because vector represented by two quantity. One is the magnitude, here magnitude is same, and direction also same, magnitude is same. Length is, if we measure this length, this is x, this is also x, so magnitude is okay. Is it direction is okay? If you put the direction horizontal to this, let's say this is making 30°, then this is also, if you put the horizontal plane, this is also making 30°. So the direction also same. So direction also same. So direction also same. So this is the equal vector. Now we can say these two vectors are equal. Earlier case we cannot say vectors are equal because earlier case either direction is same or magnitude is same. Here both direction and magnitude are same, so is equal vectors. So here is a negative vectors. So this is a negative of vector. So CD, look at CD, length is same. This is x mean this is also x. Length is same, but the direction is exactly opposite. So the DC vector is equal to minus CD vector, or CD vector equal to minus DC vector. Okay, this is a opposite vector. So the negative of vector. Okay, you understand? It's very simple. It's a negative of vector. So next thing here, look at this. We can summarize a vector like with a length. Length is a magnitude. Arrowhead is a direction. This is how we are representing. Arrowhead pointing the direction, and the length is a D, is a magnitude of the vector. Okay, some books they put tail and head with this direction arrow and the magnitude like this. It's in old days, in some books they do different notation, tail and head, both are same, starting point, end point, starting point, terminal point, everything is the same, but the basic concept is actually a vector having a magnitude and direction. Now look at the addition of vector. Now we are going to the mathematic addition, subtraction. Okay, how we add the vector. Here if we want to add the a and b vector, we just have to start with a. Okay, let's say we starting with a vector, we draw the vector first. Okay, then with at the end of end point we start the another vector, that is a b vector. Okay, now then A plus B will be, we join the starting point and the final ending point. Okay, this is a plus B. This is a come from the mathematical proof and mathematical concept. This is how we do the vector addition. We start simply, we start the vector here. Look at here, from, let's say, from O A B. So OA is a vector A. Okay, so OA vector plus, plus mean at the, when vector finish, we start another one at the end point of the OA vector, we start the AB vector. AB vector. Now the answer is OB vector. That will be A plus B. So this is a vector summation, addition of two vectors. You can see here, this is a PQ vector here plus QR vector will be equal to PR vector. Always is like that. If you have three vectors, it's very simple. You put the first vector here, then at the end point, you start the second vector, and now the very original starting point connect with the final end point. This is a final, sorry, this is a final end point. So this become the final vector. Okay, so that's very simple. Okay, addition of vectors. So here, what is here? We have the law is called the parallelogram law. As illustrated in the below image, two of the edges of the parallelogram define A plus B, and other pair of edges define B plus A. Both are same. Okay, both sums are equal. So here, look at this thing. Okay, we from the point O, let's say start from O, we draw one vector, that's a vector A, then draw the another vector, vector B. Now from, we are going to add A and B, then from the starting point we join the final end point, so it become A plus B. Similarly, we can add the B plus A. We start the B first, okay, then we draw the A vector. Now the same thing, this starting point to the end point become a B plus A vector. So this line either we can call A plus B or B plus A vector. This is a very simple. Okay, you can draw this in the coordinates, XY coordinates, to understand more and measure it, and you can prove it by using the coordinates, XY coordinates. You can easily prove it. It is equal. Okay, length you can measure it, you can prove it. Okay, now look at this. This is A vector, this is a minus A vector. Earlier, that's why we understand negative vector. We learn about negative vector for some purpose. Okay, instead of subtracting, we are going to add a positive vector and negative vector later. So this is a vector, this is a minus A vector, because the direction is same, exactly same. There is a parallel to this one and this one are parallel, so the direction is same. So we define subtraction. We define subtraction as an addition. Okay, here, sorry, in the vector concept, there's no concept for subtraction. We have only the concept of addition. So what we are going to do, instead of saying B minus A, we say B plus minus A. It is very simple. Instead of saying B minus A, we say B plus minus A. So B, we are going to add the minus A vector. With B vector, we are going to add the minus A vector. Okay, this is the concept of how we are subtracting B minus A. Okay, look at here. We are going to subtract vectors. Okay, so here, what happening? We draw the vector. Actually, we draw the vector. We do first, then explain. This is A vector. Then we put the X vector. We don't know X vector. X is going to be the answer, X vector. So, what we are doing, A vector plus X vector equal to B vector. Okay, this is going to be b vector. So x vector will be equal to b vector minus a vector. So we actually, the purpose is to subtract b vector minus a vector, that will come through the x vector. If we look at here, okay, here we have the starting point is this. We have the b vector and we are adding a minus b vector, so that we will get the a vector. Okay, so this is the subtraction in different forms. Okay, now we come to the application. This is a basic mathematics concept. We come to the application where we want to use this vector in electrical engineering. In RL circuit, we need to find the V, this source voltage, Vs. Sometimes we put Vs. V source voltage equal to Vr plus Vl. But we cannot simply add, because Vr and Vl are 90-degree phase shifted, because we know that Vr is the in phase with the supply voltage, so that is always in phase with the current. So we have a current here. In phase means there is no phase difference between this current and this voltage. So I is here, okay, and this Vr going to be like this, in phase with the current. So this is a Vr represented. We know the inductor, the voltage across the inductor is 90-degree phase leading to the current. It's leading to the current. That's why it's 90-degree leading. We always measure the leading, represent the leading in the anti-clockwise direction, CCW, anti-clockwise direction is leading. So now VL we have to represent. Okay, I draw the one vector, this vector of VR. This vector I draw already. Now I'm drawing the next vector, the VL, in 90-degree shift. So this is a VL vector. This V is a vector summation of these two vectors. Okay, this is your V. This is your V. Okay, if you put Vs here, then we can put the Vs here. Usually we put source voltage. So to understand the RF circuit, what is a vector summation? We are using this vector knowledge, because this having the phase shift. RC circuit also we have the phase shift. R across the inductor, sorry, and across a resistor, voltage drop across a resistor is always in phase with the current, because there is no phase shift between the voltage and current in the resistive circuit. If it is resistor, okay, so this VR, I'm drawing the VR first. I'm drawing the VR first. I'm done with that. Now I have to draw the VC. VC, I know that current is leading. Current is leading. Voltage is lagging. In capacitive circuits, voltage is lagging. How much is lagging? 90-degree lagging. So VC, I'm drawing in 90-degree lagging. Current is leading. Then the O to the final point. This is your V. This is your V. This is how we are drawing we can draw this one as well, in the VR here, VC here, and your VS supply here. Some books we put VS is a supply voltage. If you put VS here, and this is your VS. So this is how we understand in the RC circuit what is going on in the RC circuit. So now we can able to read a phasor diagram. So look at here, this V and IR are in phase, because it started at same point and it ended same point. It get the peak at the same point. The peak are at the same time. If we draw the line, the peak is falling in the same line. So it's showing the same behavior. So V and IR are in phase. But look at IL. IL started after in the mid of peak point. So it means 90 degree. Okay, it is in the 90-degree phase shift. IL is in 90-degree phase shift. So how we have to represent the vector diagram? We put I here, I and V are in phase, IR and V are in phase, but I is lagging because it's late. These waves are started here at 0 time. Okay, in terms of time, it started 0 time. It started a little bit late, so it is 90-degree lagging. Okay, this is understanding. Through this vector understanding, we are can able to draw this diagram. This is a purpose of today's video, to teach you the basic vector knowledge. Thank you very much. Please subscribe the channel and continue support. See you in the next video. Thank you.